this video, we're going to be looking at the enVision's Algebra 2 math book. We're going to be in topic 5.5, and we're looking at example 3, dividing functions. And the example says, how do you define the quotient f divided by g? So we have, let me grab my pen, f divided by g for the functions f of x equals x minus 7 and g of x equals 2x squared minus 13x minus 7. So to define the quotient of the two functions, we need to use the quotient rules for each function. So I'm going to write this as f divided by g of x equals f of x divided by g of x. Okay, so using this rule, I'm going to use substitution. Alright, so f of x is x minus 7 divided by g of x, which is 2x squared minus 13x minus 7. Alright, so the thing here is I now need to divide, I need to simplify this division. So I'm going to actually put the denominator in factored form. So the two factors that I'm looking at are going to be 2x plus 1, because 1 times 7 is 7, and then x minus 7. Because again, 2 is a prime number, 7 is a prime number. We have to do 1 times 7 for this. We need to get 13 as the middle term. So you need to do the 2 times 7 to get 14. And then minus 1 will give you 13, or the other way around, because it's a negative 14 plus 1. All right, so looking at this, we do have a factor in the denominator that is similar to a factor in the numerator. So those do cancel out. And we are left with a simplified version of 2x plus 1. Now the quotient, now I could say that the quotient of f divided by g is equal to 1 over 2x plus 1. And the domain here, because remember now, we have a rational function and the denominator cannot be equal to 2. So I'm going to look at this step before we crossed anything out, and I'm going to say each of those equal to 0. So my domain here is x cannot equal 7, nor can x equal negative 1/2. Because if x equals those values, we get a denominator of 0, and with a denominator of 0, we get an undefined expression. So our domain here is all numbers except for x equals, when x is equal to 7 and negative 1/2. So there you go. There is the division of two functions.